Elon Musk's latest announcement on Twitter has set the tech world abuzz. Tesla is primed to introduce AI-powered humanoid robots, with low production slated for 2025. These robots, dubbed Optimus, are intended to be genuinely useful, suggesting a future where robots with human-like characteristics might become part of our everyday lives. But despite the excitement, there's a pressing question. Will these robots actually live up to the hype? Or will they remain another ambitious vision that falls short of reality? The idea of humanoid robots isn't new, but practical versions have always seemed just out of reach. For decades, engineers and scientists have tried to create robots that can do more than just follow simple commands or navigate controlled environments. Yet here we are, still waiting for a breakthrough. Tesla's Optimus will join the ranks of other humanoid robots like Boston Dynamics' Atlas and Figure AI's Figure 01, all of which promise great things. But are we finally on the crux of achieving what's been a persistent challenge for so long? Humanoid robots typically take the form of a bipedal platform, capable of walking, sometimes even jumping, with robot arms and hands attached to manipulate objects. These robots are designed to navigate complex environments and perform tasks that require a high degree of dexterity. But let's not forget that these robots face enormous engineering challenges. Achieving stable bipedal locomotion across varied terrains, for instance, is incredibly difficult, a task that took humans millions of years to perfect. Another major challenge is dexterity. Human hands are incredibly versatile, capable of manipulating objects of all shapes, sizes, and fragility. While companies like Shadow Robot have made significant strides in developing robotic hands, they're still far from matching the subtlety and precision of human touch. Moreover, the human body's tactile capabilities, with its soft and flexible skin, are still unmatched by robotic systems, which remain limited to basic contact points. But it's not just about replicating physical abilities. The next frontier for these robots is artificial intelligence, which needs to be sophisticated enough to allow robots to plan, navigate, and execute tasks autonomously. Moving from automating specific tasks to improvising in a dynamic, real-world environment requires significant advances in AI, sensing, and mechanical capabilities. And then there's the issue of communication. If a robot looks human, we expect it to communicate like one too. This is where things get really tricky. If a humanoid robot can't replicate the micro-expressions and nonverbal cues that are so essential to human communication, it risks coming across as creepy or unsettling. Our brains are wired to pick up on these subtle signals. And if they're missing, the robot might fail to connect with us on an emotional level. This is just one of many challenges that researchers in robotics and human-robot interaction are grappling with. There's also the question of how these robots will perform in real-world conditions. Environments that are noisy, unpredictable, and filled with dust, rain, and heat. Robots are often tested in controlled environments, but the real world is far less forgiving. So, why do companies like Tesla continue to push the envelope on humanoid robots? Couldn't we focus on creating robotic systems that are more robust and better suited to specific tasks? One reason for the focus on humanoid robots is that our world is built for humans. Our buildings, tools, and cities are designed to accommodate our physical form, so it makes sense to create robots that can navigate and interact with this world. However, this approach has its drawbacks. Our environment often assumes a certain level of strength and dexterity, which can disadvantage many people, including those with disabilities. Introducing humanoid robots might exacerbate this divide. Instead, perhaps we should be thinking about how robots can be part of a world that better accommodates the diversity of human bodies. By integrating robotics technology into our buildings, furniture, and tools, we could create environments that are smarter and more adaptable, making them accessible to everyone. Yet the current generation of humanoid robots doesn't reflect this diversity. They are often designed with a narrow vision of what a human body should be. So why are we so fixated on creating humanoid robots? It might be that there's a deeper, almost mythological desire to create versions of ourselves. This fantasy has been explored time and again in dystopian science fiction. And it seems the tech industry has taken this narrative to heart. Or perhaps humanoid robots represent a kind of moonshot, an incredibly difficult goal that, while not entirely practical, pushes the boundaries of innovation. In the end, whether Tesla's Optimus or any other humanoid robot will succeed in becoming genuinely useful remains to be seen. The challenges are immense, and the path forward is uncertain. But even if the ultimate goal of a fully functional humanoid robot remains elusive, the journey towards it could lead to groundbreaking advancements in robotics, AI, and human-robot interaction. Sometimes, it's the pursuit of an idea that drives the most significant innovations. As we stand on the brink of what could be a new era in robotics, it's worth asking ourselves, do we really need robots that look and act like us, or should we be focusing our efforts elsewhere? The answer might not be clear, but one thing is certain. Tesla's venture into humanoid robots is set to push the boundaries of what's possible, and the implications of that could be far-reaching, whether or not these robots ever live up to the vision that inspired them.